Hello, grade 12s, how are you? Mr. Nulab is here again. If you have not subscribed the channel, you can subscribe it. Today, I want us to look at contingency table. I've done one video on this one, and I've decided to do another video for other section on the contingency table. Okay, this is a past question. Let's look at this. It says a tournament organizer conducted a survey among 150 members at a local sports club to find out whether they play tennis or not. The results are shown in the table. So those who play tennis, those who do not play tennis, male and female. Okay, now the question says, what is the probability of what's the probability that a learner selected at random is female? What is the probability? Let's see how we're going to do that. I've drawn the table again. So when you have a question like this, what you need to do is you add all of them, find the totals. So here we are going to find the totals. So let me get my calculator. Where is my calculator? Here you are. Okay, so we are going to find the totals. So 50 plus 20 is what? 70. 30 plus 50 is 80. 50 plus 30 is what? 80. 20 plus 50 is what? 70. So easy to find to find the totals. You can either add this or you can add that one. Alright. So 80 plus 70 is what? 150. Are we together? Okay. Now, after we get our totals, the next thing we are going to do is I want this one somewhere there. I want to split this thing. Okay, now we have our table up there, the one that we fill. Okay, so look at the down here. Now the question says, what is the probability that the person will be female? Let's get back to the question. It says, what is the probability that a member selected at random is female? So here, a member selected at random, where is the female? Female. The total number of female is what? 70. Alright, so it's going to be 70. Total number of female, if you look at this, total number of female is what? 70. So it's going to be 70 over the ground total, which is 150. So 70 over 150. Okay. Then the next thing, what is the probability that a member selected at random is female and play tennis? The person is a female and that person also play tennis. Where are we going to get that one? Okay, from our table, the person is a female and the person plays tennis. So it's going to be 20 over 150. 20 over 150. Okay, then the next one, what's the probability that the person selected is playing tennis No, okay, this one is a different question, not from that one. So it says, is playing tennis independent of gender? Motivate your answer with necessary calculation. Is playing tennis independent of gender? The first thing, we need to remind ourselves of independence. When two events are independent, what can you say about them? Okay, when two events are independent, if you multiply their probability, it should be equal to the intersection of the two. Let me write it mathematically for you to see what I'm talking about. Okay, if for instance two events are independent, what can you say is okay, when two events are independent, their probabilities, that is their probabilities, for instance, probability of the two events occurring together, like A, assuming the first event is A and the second event is B, so probability of A intersection, I need intersection here, probability of A intersection B should be equal to probability of A times probability of B. Okay, now I want to write it A intersection B. Okay, this is my intersection, A intersection B, that is A and B. In other words, A and B. Let me put it this way, A and B. Probability of A and B should be equal to probability of A times probability of B. That's the meaning of A intersection B. So probability of A times probability of B. But this question is asking, is playing tennis, that is if you play tennis, independent of gender? In other words, if you play tennis, for it to be independent, it means playing tennis, which is this one, the whole of this is playing tennis. So those who play tennis, it can either be female or male. So for instance, we can make our A to be those who play tennis and our B to be those who play tennis and they are female, or those who play tennis and they are male. We can choose any of them because it says independence of gender. So we need event, what event? Those who play tennis, and also another event, gender, and the gender can either be male or female. Is that okay? So our A can be those who play tennis and our B can be those who play tennis and they are male, or those who play tennis and they are female. Okay, so here what I'm gonna do is I'm going to find those who play tennis, those who are females. I'm going to find the total number of female, those probability of those who are female. Probability of those who are female is 70 over
and make me whole. He brought Jesus Christ to bring me divine health, to bring me peace and love, and make me whole. He brought up Jesus, he brought up Jesus, he brought up Jesus. Take away my soul, to take away my soul, to take away my problem, make me whole. He brought up Jesus.
Okay. Now, probability of those, we are going to find probability of those who are female. Probability of those who are female is total number of females, what, 70 over the ground total, which is 150. Then the probability of those who play tennis is 70 over 150. So here, let's look at probability of those who are female and play tennis. Probability of those who are female and also play tennis is going to be 20, this one, over 150. So that gives us 0.13. Now for them to be independent, it means if I multiply this and this, I should get this. How? Let me show you on, remember I gave this scenario at the top here. This scenario of independent. For it to be independent, for A and B to be independent, what should happen? For A and B to be independent. For A and B to be independent, probability of A and B should be equal to probability of A times probability of B. Alright, and this is our probability of A. Let's call this probability of A. Probability of female is probability of A because female is a gender. And probability of playing tennis is probability of B. That one is for those who play tennis. Probability of B. Okay. Now we said probability of A and B should be equal to probability of A and B times B. So what is probability of A and B? It means those who play tennis and are female, or those who play tennis and are male. We are only using female. So here, probability of A and B is going to be, A and B is going to be this one, those who are female and play tennis. Alright, which we had it to be 20 over 150. We got it from the contingency table. Let me show you. Where is it? Where is our table? This is our table. Those who are female and play tennis is what? 20 over 150. Is that okay? So here we need our probability of A times B. So let's see if they are going to be equal. Probability of A, what's probability of A? 70 over 150. What's probability of B? 70 over 150. So if we multiply 70 over 150, what are we going to get? 70 over 150, and this is going to give us 0.22. Alright, if I multiply them, if I multiply these two, let's multiply and see. over 150 70 over 150. And this gives us this value. If I convert it, it's going to be 0.21, which is 0.22. So if you check this one, that is probability of A times B, which is this one. Probability of female, or probability of those who play tennis times probability of female. It gives us this value. Then probability of female and also play tennis, it gives us this value. They are not the same. So we can say that therefore the events of playing tennis and gender are not independent. If you check, they are not the same. Probability of female playing tennis, we had 20 over 40. Where did we get it? We got it from here. 20 over 150. And probability of female, which is 70 over 150, times those who play tennis is 70 over 150. When we multiply it, we got this one. They are not the same. They don't give us the same answer, so we cannot say they are independent. So therefore the events of playing tennis and gender are not what independent, because they are not the same. Okay, let's move on to the next question. Okay, each passenger on a certain Banana Airway flight choose exactly one banana from tea, coffee and fruit juice. The results are shown in the table below. So we have our nice table here, and they want us to answer question using the table. So here the question says write down the value of A. What's the value of A? You can just add this, or you can add this one. It must give you the same answer. So our value of A, you add 60 plus 100, 160. Or if I add this one, it must give me the same answer, 60 plus 80 plus 20, 160. So any of them, you can either add here or you can add here. So that gives us the value of A. Okay, so our value of A is 160. Then the next question says, what is the probability that a randomly selected passenger is a male? Where is our male? Randomly selected passenger, total number of male is what? 60. Divided by total, ground total, which is A. And A is what? 160. So it's going to be 60 over 160. We can simplify our 60 over 160. And it's going to give us 3 over 8. And I know you don't have problem pressing this on the calculator. So this is going to give us 3 over 8. Which is the same as 0.375 if you write it as decimal. Okay, the next question. Given that the event of a passenger choosing coffee is independent of being male, calculate the value of B. Okay, so if they are independent, it means being male, given the event of a passenger choosing coffee. Where is coffee? This is coffee. Is independent of being male. Okay, so independent of being male. So it means choosing coffee. What they are trying to say is this B over A should be equal to, for you to be male, for it to be independent, 60 over A should be equal to 80 over, no, 60 over A times 80 over A should be equal to B over A. Because for it to be independent and also drink coffee, those who are independent and drink coffee, those who are male and drink coffee is B. The probability of those who are male and drink coffee is B over the ground total. For it to be independent, this B over A should be equal to those who are male, the probability of those who are male times the probability of those who drink coffee, for it to be independent. Remember, it's supposed to be probability of A and B should be equal to probability of A times probability of B. So here we are going to use that idea here to answer this. Probability of male and probability of male times probability of those who drink coffee should be equal to probability of male and coffee. So for it to be independent, good, for it to be independent, that is what it's supposed to be. So here, probability of male, what is probability of male? Probability of male is 60 over 160. Remember, our A is 160. Né? We found probability of A male even here. Okay. Probability of male is what? 60 over 160, which gives us 3 over 8, which is this one. And probability of those who drink coffee, how do we get that one? Probability of those who drink coffee is what? 80 over our A, which is 160. Let me put 160 here. So probability of those who drink coffee is what? 80 over 160. It should be equal to probability of male and coffee, those who are male and they drink coffee, which is B over 160. If I simplify this one, remember, if I press this on the calculator, what am I going to get? I'm going to get 3 over 80 times 80 over 160, which is going to give us 3 over 16. So we have 3 over 16 should be equal to B over 160. Now if I transpose this, if I transpose this 160 to this side, it's going to multiply. Alright, so we are going to have 3 over 16 all times 160, or 3 times 160 over 16, and this gives us 30. Okay, let's move on to the next question. Our next question says, a survey was conducted among 100 boys and 60 girls to determine how many of them watched TV in the period during which examination were written. Their response are shown in the partially completed table below. So this one, we have this information. What do they want us to do? Calculate the values of A and B. They want us to calculate the value of A and also the value of B. So before you can do that, let's fill the table. This is our table, A and B. This is 160. So it means to find B, it is I want small letter B. To find B, how is it going to be? You add all this, 80 plus 48. What would I give you? So we have 80 plus 48, which gives us 128.
and make me whole.
Then we know we can also find A. How do we find A? It's 32 minus 12, because A plus 12 should give you 32. So to get A is going to be 32 minus 12. It gives us what? 20. So A here is what? So one small letter A. A is 20. Okay. Now we can find our totals. Probably we will need them. So if A is 20, what is going to be this side? 80 plus 20 is 100. Then let's check this side. 48 plus 12 is 60. So 100 plus 60 is gonna give us 160. Okay, so our first question is answered. Remember, A plus 12. A plus 12 is what? 32. So 32 minus 12 gives us 20. So A is 20. Then our B, 80 plus 48, which gives us 128. We are done with that question. Then the next question. Are the events being a male and did not watch TV during examination mutually exclusive? Are they mutually exclusive? That's the question. Let's see how we are going to. Remember, for mutually exclusive, we know that there shouldn't be intersection of the two. Probability of A intersection B should be equal to 0 for two events to be mutually exclusive. So here, what we are going to do, they said, are the events being male? Where is male? The whole of that. And did not watch TV during examination mutually exclusive. Did not watch TV. So here we are talking about A. If like A is 0, you say it's mutually exclusive, but it's A 0. No. So to answer this question, we say no. Why? Because probability of being male and not watching TV is A, which is 20 over 160, and it's not equal to 0. So we are saying it's not mutually exclusive. Okay. If a learner who participated in this journey is chosen as random, what is the probability that the learner watched TV in the period during which examination were taken? The learner watched TV in the period during which examination was taken. So for the learner to watch TV, it's going to be this is the total number of learners who watch TV. So 128. Remember, we found B to be 128. Alright, let me show you here. We found B to be 128 over 60, the ground total, and this one gives us 4 over 5, which is the same as 0.8, which is the same as 80%. Then it's not a male and did not watch TV in the period during which examination were taken. Did not watch TV in the period during which examination was taken. So if it's not a male, because the question says it's not a male, there's the question. Not a male. If it's not a male, then it's a female. So they want females that did not watch TV. So female that did not watch TV. So here we are going to have female that did not watch TV, which is 12 over 160. This 12 over 160 and gives us 3 over 40. Okay, so this brings us to the end of this section. I want you to do this work for me. Are you ready? Okay, this one, this is our contingency table. Similar work. The same information, just change of numbers. So you are going to do this for me. This time it's not a female, it's a male. I'm adding more questions, so it's a male. The first one, A. Then the second question, this time it's not a female, it's a male, and plays tennis. It's a male
to bring me peace
and play tennis. It's a male
Jesus to take away my sorrows, to take away my problems
and do not
and make me
play tennis.
Jesus Christ to bring me divine health, to bring me peace
Okay, so here
and make me
you are going to do that for me.
Jesus to take away my sorrow, to take away my problem
Okay,
and make me
then our next question is going to be this one. Question number 2. Your question number 2 is this one.
Give me divine health.
This time is like this. How is it gonna be? I'm changing this one to 80. Let me make it 70. Just change it. So it means this one is going to be 170. Are we together? So you do that one. Find the value of A. Then what is the probability the passenger selected is not a male but is a female? Okay, nice one. And it's now female. Let me add FE. Change everything. They are all similar questions. It's just practicing question, eh? Okay, then This one also, this must be 2. Then this one 2.3. Given the event that the person chosen coffee is independent, this time is not chosen coffee anymore. It's going to be different then. It's now going to be the event of the person that choosing coffee is independent of female. Okay, let me just leave it like that. Okay, now we are going to say bye bye. Bye.